Everybody. My name's James Pick. I'm one of the UAV strategists at Coptrz, and I am an engineer surveyor by trade who's worked in the offshore industry and engineering industry on land as well. And I'm joined with my colleague George as well.
Yeah, thanks, Jim. Thanks for having us, guys. So I head up the inspection side here at Coptrz, which looks over the renewables, heavily involved in the utility sector, so water, and basically any of the natural power here in the UK. But no, really appreciate you joining us. Today we're going to look at sort of drones in the marine industry, but have a bit of a general topic. So it's more on the traditional inspection and survey. So if you'd like to hop on. There we go.
There we go.
So just give you a bit of a background on what we do and who we are. Coptrz started around about 5 years ago, and we actually came from the marine industry where once upon a time we were known as Martech Marine. We worked with a lot of companies around the world by providing safety equipment, fast cow gas, and yeah, lots of different innovative ideas basically. And some of our biggest customers once came to us and said, we're interested in drone equipment. We're looking to do surveys and inspections on some of our wind farms and turbines. Is this something that you can help us with? Our founders, had that eureka moment and started Coptrz, which is primarily UAV supply, UAV equipment training. So now we've evolved into a 360 drone solution provider here in the UK, as well as mainland Europe. And we've partnered with some of the world's biggest drone providers. We've got, obviously, if anybody knows anything about drones that's with us today, you'll recognize DJI, you'll probably recognize Pixel D and Flare, maybe Parrot. And we are going to talk a little bit about the wing strut and flyability. So keep your eyes peeled for that, because they've got some really great applications for especially the marine industry and obviously ports, etc. Some of the larger customers we work with on a day-to-day basis, from EDF Energy on some of their nuclear sites with Magnox, through to construction, so Jacobs, Costain, and then onto utilities and inspection tech, so Severn Trent and Thames. So obviously it's all well and good saying, yeah, a drone's great for doing certain things, but it's more, we've got to start looking past the actual drone itself and start looking at the application, because at the end of the day, the drone is purely the vehicle to carry a camera, to get an aerial view, to find something out that you would traditionally not be able to. And this application's been championed in lots of different sectors now, as obviously you saw before, a couple of the companies we work with, but the main ones that we are seeing a huge investment in over the last 12 months has been oil and gas, power gen, construction, utilities, and maintenance. So anything from asset inspection to site progress, heat loss, thermal, whatever it may be, I can guarantee somewhere in the UK there is somebody using drones for this job. Now, the application's all well and good, but you've got to have a selling point. And if that's from us to yourselves, or from yourselves to the end client, or from you to your shareholders, etc., you've got to either have a way of lowering costs and reducing the downtime. So if you're having to shut down a nuclear power plant, you want to be able to be in and out as quickly as possible so that you can still save money and still be profitable. But the biggest one for us, especially with some of the internal side of things, and I'm sure there's a lot of stories, and I'm sure you'll be able to educate us on that at a later stage, about the marine industry, especially with confined space entry, especially in some of these dangerous areas like ballast tanks, where safety is always paramount. And we see drones, especially for the high access, so eliminating rope access or traditional scaffolding, or even going into confined space entry, there are drones which are now eliminating this risk. So the improved safety side, working at height and then with confined spaces, is a huge selling point for drones in general. So I'll move on to key applications, and I'll hand over to Jim just for the survey aspect of this, which obviously Jim is more capable with.
Yeah.
So over to you, mate.
Yeah, so in terms of, as George briefly spoke about, the drone is really merely the donkey to carry our sensor for us to make collect some data and make some informed decisions about how to approach a particular task or subject. So in terms of sort of where we're heading within the drone industry, that ability now to put a whole wide range of really great sensors onto these drones, things like thermal cameras for heat loss or leak detection, really high-powered zoom lenses, so we don't even have to get close to that area or that target in question. We can stand far back at a safe distance. Things like methane detectors, multispectral cameras for analyzing vegetation, you know, how much water content's in there, what's the general health of a agricultural land. This is all now capable using a combination of the drones, sensors and softwares to make that analysis and make that informed decision afterwards to save ourselves money, increase yield, improve our safety, collect data faster, more efficient, more data than ever before. And this is really where the drone industry is heading at the moment. And we still are at them early stages, but we are, like most new innovative industries, moving at a very, very fast pace. So here's just an example of the thermal camera on our Matrice system. This was at a water event.
Yeah, it was Innovate East, if anybody's heard of that, with the Anglian Water. But what's really interesting to pick out is that these are all images taken from about 150 meters from the site. And with a zoom lens like you see in here, you can actually read the writing on the side of the tents quite easily. But what you see with the thermal side of it is you can see all the heat signatures. So for the likes of heat loss detection, it's a really good and easy tool to do, and it's very fast to analyze. So on the subject of thermal analysis, we'll go on to, and hopefully everybody can see this video. Just give us a little yes if you can, that'd be brilliant.
Running okay for me, guys?
Yeah,
brilliant. So this just shows the capabilities of it's called the H20T camera on the M300 series. So this is a sensor which has 3 sensors embedded into it. So it has a high radiometric thermal camera. It has a laser rangefinder, so we can actually report on the distance from sensor to object. It's got a 20 megapixel optical zoom lens and a 12 megapixel wide angle lens. That's all wrapped up into one sensor. From one click of a button, we can capture all that data for further analysis. And just looking at some of these images, we can pick up things like overheated cells. We can pick up some what looks like bird muck on the solar panels. All this, it decreases the efficiency of things like solar panels. You know, before where we'd have to send a person looking around these sites, you know, on the ground, we can fly now full solar farms in minutes as opposed to days on a walk survey. And this is where really drones are playing this key part now in efficiency, getting data fast, efficiently, and a lot of data quickly. And there's this massive increase so far in the uptake of drones across a multitude of industries, not just marine, not just inspection. So this is just a good example of what you can do with a high-powered camera. So this is on a network rail infrastructure. A network rail, obviously, for very good reasons, very funny about people flying close to their network, certainly on live track. So with an investment in a high-powered camera, so this is using a phase 1 IXM metric camera, flying 60 meters away from that infrastructure, we can make still very high detailed analysis from inspection reports, or you could actually use this data to make 3D representations of this model, either for an inspection applications or recording that infrastructure at a moment in time, so we can look back at how it was and how it's changed over time.
So what's really good about this for a practical sense is you can be that far away from a building, and because you're that far away, you have a wider field of view. And with that field of view, you can take a single image but still retain large amounts of data and high quality imagery. So when you go back to the office or you go back to site, all you have to do is zoom into the photo, and you can pick out real key points, whereas the alternative would be a zoom camera, where you'd have to pick out those points on the day, on the job. Having this high resolution photo would allow you to zoom in and pick those points out post-process.
So what we can do, certainly from my survey perspective, is we can take the 2D and turn it into 3D. So photogrammetry was a method discovered sort of around in the 1850s, where we could take measurements from photographs. This kind of way of data collection and processing was very much confined to manned airborne reconnaissance. Sort of in the First World War, it was used all the way up to now modern day with the Ordnance Survey, using it to map the UK. What was a really great advantage of now, drones being a lot cheaper and accessible, and being able to put really great cameras on it, and also this digital age we live in, about being able to process through multiple data sets fast and efficiently. Photogrammetry has almost taken that forefront again into the modern age for data processing. And photogrammetry has some really great characteristics. It's not only highly accurate. Typical sort of survey accuracies we can get down to anywhere from millimeters up to 50 mil for a land survey application, but we get this real visualization from the data as well. So we can fly a site, we can fly a boat, create a 3D representation of it, and actually we can use that from an inspection perspective, so people can actually zoom in on that area of a vessel. They can then bring up all the imagery from that particular survey, and then use that data then to make either an inspection report or use that for further analysis. And that can be done with really entry-level drones like little Phantom 4 RTKs or to some of the higher, more larger crafts with better sensors on as well.
So to give you an example of how this is being used in your sector, Bristol Port actually do volumetrics using photogrammetry of the spoil heaps that are created on the side of the port, because they have, certain companies have quotas on how much they're allowed to extract and put onto their sites. Bristol Port obviously monitor this, not by a physical survey, which could take days. They do it using drones, which take a few minutes. And because you've got that data, you can now estimate to a very accurate amount the actual volume of the spoil heap.
This is just an example of the realization side of using photogrammetry. So this was of an old abbey ruin near where I live in Lincolnshire. So you would get this great benefit of, not only is this a very highly accurate model, maybe down to sort of 10, 20 mil, but we've also got this full-scale realization and realism from the model. So something like this, you can imagine that businesses like Historic England, they can create this snapshot in time of an old ruin, an old building, an old castle, and then use this should something happen in the future. I think we all saw like Notre Dame Cathedral burned to the ground. Data captured from previous surveys can be used then to create repair orders, or use that data to restore that very easy and efficiently. Data is one of the most powerful and most useful things we've got on the planet at the moment, and comes at a cost. And if we've got these big repositories of data sets, that can only be beneficial and useful for future generations. This particular model, this was captured maybe in about 45 minutes of flying, the full model, and in terms of processing, maybe 4 or 5 hours on top. But I'm sure you can see that the results from it are really staggering. And this has only been done with an entry-level drone / camera around about £4,000 or £5,000.
We'll say for any of the videos that maybe aren't coming out, we can send you links through to all the YouTube clips that we've uploaded after the webinar.
So also in terms of photogrammetry, we have the other side of it, which is LiDAR. So this is the ability to put a laser scanner on the drone. It is faster processing time. It's not as visually pleasing, but it does certainly have its benefits in terms of things like forest canopy surveys, coastal monitoring. Use it for power line inspections and surveys, just because we have this ability to be able to penetrate through vegetation, and that signal which is released from the LiDAR can travel through any holes, any gaps, and then we can record that return from how long it takes to leave the sensor and come back, and actually then make these 3D models and 3D point clouds from that data as well. This is just an example of using it on a racetrack in the States. All this data was captured in about 15 minutes and to around about an accuracy of about 30 mil. Really where it comes in home is for things like, let's say, vegetation penetration or an even faster means of data capture and processing compared to photogrammetry.
So obviously we've spoken about it a little bit, but I think one of the key aspects of drone technology is maintaining speed, making sure that you can do stuff efficiently, and minimizing that downtime really comes into effect here, because obviously drones can be deployed and are ready to go within a couple of minutes, and you compare that to some of your more traditional methods of inspection, so rope access or scaffolding. You're comparing, really long periods of setup time before you've even got the inspection to, within minutes. So it really is comparable. Obviously, you can do a full inspection with a drone in a short period of time. This isn't to say that drones are going to fully take over and you're not going to have need for physical inspection, because at the end of the day you're always going to need a man on the ground, or certain jobs are going to need that physical touch. But this is purely a tool, a pre-site visit or a pre-inspection tool that allows you to have at least eyes on, see if there's any issues or any problems, or even just the ability to see if you need to go up. So in terms of minimizing downtime and saving you costs and saving you time, it is becoming a real key factor in the industry.
So this is just a good example of what can be achieved and in terms of how much time can be saved. So this is utilising the Coptrz fixed wing system. You can just see it pictured up at the top of the screen. Now, the great thing about this system, it's a VTOL system. So it'll actually take off and land as it's sat like a rocket. So you can set a transition altitude. It will take off in the vertical, transition forward to go into look like a traditional plane, fly the full site, then actually come back and land on its tail as well. It's quite an incredible sight to see. You can equip this with high-end Sony RX1 cameras, 42 megapixel cameras. And this is a good example of where drones can really come to their own. So this was a survey company who had been using drones for a while. And they had this job come in, which was a large survey, which was land owned by a utilities company. And they wanted to do basically a site audit on it, see what land was there, and then turn all that into 2D drawing. So traditionally that would have taken them 2 to 3 weeks with people on the ground. I think this is a two-man team with total stations and GPS to fully go around this site, and then actually a week to take that data and then turn it into some drawings. We managed to do that that full site, so around 200 acres in in an hour and a half of flying, and then on site probably took us about 2.5 to 3 hours to put some physical markers on the ground to be able to validate that data and make sure it was correct in the right area. And that probably took about was on site for maybe 5 or 6 hours, and then actually the processing side of it afterwards took about around 3 days. So that's a massive saving from what's really going to take 2 to 3 weeks beforehand, down to only a matter of days. We went out and checked that data afterwards to make sure it all tied in, and in the Z-axis was down to the 50 mil level, which was pretty consistent across the board. And this really where drones really has that power to revolutionize a lot of industries and a lot of projects. We normally get a call when a project's going a bit south, where time needs to be made up quickly. And naturally, drones are a really great option to look at to claw back some of that time and to bring projects, or potentially try and bring projects back to a reasonable time scale and within budget.
So this leads us on to sort of the biggest point, especially with the internal use of drones, and that's the increase of safety. Obviously, working at heights is a totally acceptable reason, but it's the case of working in confined space, and drones may not come as the obvious choice. But for the likes of sewers, culverts, even tank inspection, and a lot of the time even places where they are not been discovered yet. So cave areas, I know we've got a good video coming up of a cave area, which was a totally new exploration. It's saving the lives of humans by putting them in dangerous areas by replacing them with technology, with robots. And obviously, with the likes of COVID-19, certain sites around the country obviously closed off because of that. Insurance required them to have full site surveys to maintain that their equipment wasn't being stolen or it wasn't being misplaced. Flying drones over from outside of the site, maintain that they were able to identify that sites were still in good nick. So this leads us on to the Helios 2, which for the marine industry, we're seeing a huge demand for this, where it's over the last 3 to 4 years since the original Helios 1, the marine industry has been one of the biggest advocates of the Helios system. So if we move to the next slide, this is the Helios 2. It's a Swiss-made aircraft designed for contact and designed for confined space entry. Obviously, you see that it's got a cage around the propellers and around the mainframe of the drone, which allows for stability. Also allows that if you do, bounce into something or you do hit something that's unexpected, because sometimes you're going into areas, especially into new unfound areas, you are going to be finding some new obstacles, so to say. But obviously, the actual drone itself fitted with a 4K camera, fitted with 10,000 lumens. So if you can imagine a completely blacked out room, it will fully illuminate the area. It's got a thermal camera, but as we move on, we'll be able to show you that the drone actually has sensors around the mainframe, which keeps its distance from certain obstacles. So if it's in a room, it's got 7 sensors around the drone which keep it at a fixed height, but also a fixed distance from that wall. This basically means that you're keeping and maintaining a safe distance, which will increase your data accuracy and data quality. You're not having to fight the drone to keep it stable. You're not having to worry about that. Drones are a thing of the past where it was drones designed for drone pilots. Drones are now being designed and being built for operators and people who have an application. That's where the market about a year ago really took a turn, and we're seeing a lot more applications and a lot more champions coming from the physical inspection or the survey side rather than being a drone expert.
I think the interesting thing what George is pointing on there is it's much easier to train up an inspection specialist, an NDT inspector, to fly a drone as opposed to a drone pilot training them up to learn the inspection side of it. Or it's always good to have that prerequisite knowledge as an inspector and to learn to fly a drone, which can be easily done in a few hours, as opposed to getting a drone pilot to fully understand the inner workings of a vessel or a boat. And we're seeing that shift in industry now. We'll see businesses use a subcontractor for a while, potentially, just to almost, I call it the canary down the mine. So they'll get a subcontractor in to use a few times so that they can collect some data, they get a feel for it, they can have a bit look at the workflow. Then 9 times out of 10, they'll realize that drones is a great investment and then actually decide to invest in themselves.
Another great feature which a lot of people don't understand about drone technology is if you stick a laser sensor on the front, you can actually work out or estimate or give an approximate measurement of what you're looking at. So because you know the X, you can understand the Y. But so let's take a ballast tank, for example. If you're doing the seal around the side, you can get to a single point and fix the distance, and that drone will not move from that distance away from the surface. So as you see here, you can move up, down, left or right, but you will not move any further away from the surface that you're looking at. So for the likes of a detailed inspection or survey, it really does give you some fantastic information, fantastic data that you can then put into the likes of photogrammetry or likes of your reports, which you'll be then given to the end client. And this is actually a ballast tank inspection that was done with the Helios 2. And I'll let the video do the talking, because it's such a great application that I think a lot of people will agree really does show the key characteristics of the drone.
When you say the Helios 2, you say it's an easy to fly.
Yeah, in terms of drone technology, it's so easy to understand and use. If anybody's ever played video games, it's nothing on that. It's so much easier.
So this has been quite easily navigated through numerous floors to collect that information. required.
And obviously you can see that the amount of illumination that it's causing from those LED lights around the drone. And you may have seen just as it came in that there was a lot of dust kicking about. I mean, that's quite normal because you have got the propellers moving at quite a rate that it will kick some of that up. But the lights are designed now so that they're further around, so the actual refraction of the dust particles that the light is causing is minimal. So it's actually cutting through, so that the actual image that you're seeing is a lot purer and a lot more detailed. And obviously the stability as well. Even just standing still, it almost feels like it's a human with a head torch on and a cam in front of them.
As we sort of said, it's all about data quality, and I'm sure you'll agree on the downlink that this data's good enough to make any sort of decision-making process from there as well. Also with the new software as well, which has been launched on the Elios 2, you'll map this area using the video feed. So if you do find an anomaly, you'll be able to backtrack from that and say, well, actually, this anomaly is 3 meters away from this porthole, which is a new feature which has been added in the next couple of weeks, just in the beta testing stage at the moment. So you can see we've covered some quite incredible distance with the drone, and it looks like we're now heading back.
All of this footage is constantly recording, so as an operator, you don't have to worry about potentially picking something out. You can go back through the footage and then identify or investigate post that. But as you see, not a difficult thing to do at all.
And that's gone from one side to the other.
Yeah, one side to the other, and it will now fly all the way back in its own time.
You're not flying this way, George.
It wasn't me this time, no. Traditionally not the best aircraft for outdoors, purely just because of the wind that can be created, and it does act like a kite sometimes, but here we're seeing it's a really good application. So another application which is more internal use is just showing you how this information can be captured. This was done actually at a very well-known food and clothing. How would you describe them? This isn't just a distribution center, is all I'll say. But yeah, here we were asked to go into it was actually a handover day for equipment. So we're looking at the motor. Traditionally, what they do is they shut that runner down for 24 hours before they could move on, just so they could get their rope access teams up. So if we move to the next slide, we'll actually see the data quality. So that top left image is the image that was captured, and then in the post you can zoom in and actually look at what you want to see in a little bit more detail. I was still quite cautious to get majorly close to it, so I maintained a distance, but then I was able to zoom in and get some good information. And then I mentioned briefly about investigation and exploration. This is absolutely key. This is the Elios 2 following an Elios 2 down a Swiss caving system. Now some of these areas and some of the offshoots will never see the light of day. Humans will never be able to get into these areas, but with a drone we're now able to investigate some of these parts of the mountain and give us an idea of what's down there. And you can imagine for the likes of search and rescue, it's a fabulous tool to have. So what you're seeing here is a 3D reconstruction using photogrammetry, and all of the images taken from the drone that is captured. So if we zoom in up to some of these areas up here, these areas will have never been viewed by humans before. And every single dot that you see there is a point of interest which was captured by the drone, rendered into photogrammetry using Pix4D, and then stitched together using the software to give you a representation of what it would look like. and that's just something we did quickly in one of the ducts in our offices, actually. Someone left the broom out, if you can spot that.
So this is just a good example of how the Elios 2 has also been used in the marine industry as well. You might have seen the name. They've now gone for the Elios 2, and if I show you this video, I hope I just showed the many applications and the great data you can get from the Elios in your industry. Here's just some other examples which my colleague George captured from a vessel inspection. I don't know if you've got any more information you want to share with this.
Yeah, it was just it was purely a tank which was out of service. They had the occasional inspection to do, but the actual seals on the roof, well, it would cost too much for them to inspect. So it's never been done in the last, I think it was up to about 8 years now. So to get a drone up there and to check all the welds and all the bolts were still intact was yeah, a massive win for them. Obviously, confined space entry is a huge talking point in the offshore and onshore oil and gas industry. So yeah, it was a big win for them.
Excellent. I think as George said, that this was all captured outside the vessel. The Elios was flown directly in to capture that. So, you know, out of contact, non-contactless inspections away from safety is the main key areas with the Elios. And this was just a video from that particular survey. So George was stood outside. I know there was a couple of inspectors in there. They wanted to see it in action, but George was controlling this all from the externals of the vessel. So things like weld seam inspections, you can really use all the features of the Elios to actually lock onto a particular target and pan round. So I said, as an inspector, to start using drones, it's not a steep learning curve as such. A few hours of tuition, you can start flying this piece of equipment like you're a seasoned pilot, and collect all the sort of data for further analysis.
Yeah, exactly. That, as I say, this is an inspection which would potentially be put off and not done. So being able to tick all the boxes and offer something that maybe a competitor wouldn't be able to do at a reasonable price is a real win for a lot of companies. This is a bit of a basic roof ceiling, but we did a flight with Oceaneering down in Cardiff a couple of weeks ago, and the roof structure had a lot of beams, and it was a fun and exciting way to fly through, and it performed brilliantly actually.
But that was like must have been about a 30-meter diameter tank, wasn't it?
Yeah.
It's 4 weld seams, all done from the outside in probably 35 minutes, something like that.
If that, yeah. So this is what I was talking about, the distance lock. You're able to lock onto the wall and basically just pan around the whole thing, capturing consistent information, and using different lighting techniques that the drone has. You can check the oblique lighting, so if there's any deformities or any cracks, you'll be able to pick them out quite well.
So yeah, just to wrap up, in conclusion, I hope we've showed you the real benefits of drones, and that using ourselves as Coptrz as that partner to be able to provide everything from the training, the equipment, the software to go with your applications and help and assist you along that way. That's something which we do at Coptrz, and we really pride ourselves on in that support for yourselves. We're always available at the end of the phone, yeah. Basically, that's concluding from ourselves, me and George. Really great to hear from you guys. And if you have any questions, please feel free to ask them now.
Wow, George and James, thank you very much. I find this technology absolutely fascinating. Do you think in 10 years' time, every marine surveyor is going to have a drone in their toolbox? Is that what the modern surveyor's toolbox might look like?
Absolutely. We're seeing it now. I know traditional survey companies, they're using drones 2 or 3 times a week now, whereas maybe 12 months ago, 2 years ago, they might only use them once a month. And there's more and more people investing in drones at the moment because they understand these to be a really, really great tool for future use. We always say we can't stop innovation, we can't stop progress. It's happening. People are using these. We're past that stage now, I feel, of used cases and proof of concepts. You'll only have to look on the Flyability Elios 2 website, and they've got hundreds of case studies where drones have been used across multiple applications and platforms. So yeah, that's kind of where we see it in terms of drones and toolboxes. Absolutely, 100%.
I think it's really interesting. I think the whole thing we were just talking before you guys came on to present about deaths in enclosed spaces and confined spaces and so on. There's a huge win here, I think, isn't it, in terms of health and safety, if nothing else. And I was amazed, just that last video you were showing, looking at weld seams and so on, the quality of the imagery is quite remarkable. So they've really come on in the last 4 or 5 years since they sort of started really hitting the scene.
Absolutely. Any other questions from the
I don't know.
team?
Anybody want to ask anything specifically? Have we blown you away with the technology?
That's it. I think we still are at the very, probably 2 or 3 steps into where drone technology is heading. More and more new sensors, better quality imagery has been able to be achieved and collected from these drones. This thing before of collecting data efficiently, easily, as George touched on before, you don't have to be a model plane enthusiast. You don't need that skill anymore. These drones, I could guarantee we could put you in a car park, get the drone out of the box, and within a few minutes you could easily navigate and fly these drones. So it's nothing to be scared of. Get involved, basically.
And I suppose for a surveyor who, an independent business who doesn't necessarily want to incur the cost, it's knowing at what point and for what type of job they would call a specialist such as you guys in. I think that must be a bit of a challenge.
Yeah, so how we're geared up at Coptrz is we're solely on the reseller and an enabling business. So we work very closely. We don't get involved in the service ourselves. Main reason for that is because, you know, if we don't want to be in competition with our client base. I know if I'd spent good money on a piece of equipment and I saw that company doing work which I could be doing, I know it'd leave a bit of a bad taste in my mouth. So how we're structured is we will enable a business and we will help and support. If still the company doesn't want to go down that route, then we'd much rather put yourselves in contact with businesses who have purchased from us, who does have that that specialism in that particular industry, to assist you through that route.
So just going back to the one on the ballast tank, or the ship ballast tank, were you called in by a surveyor, or were you called in by the vessel owner, or how did that work?
So I think that particular one was Flyability. The manufacturers themselves were called in to actually perform a proof of concept. This is when the Helios 2 was first out, maybe 15 odd months ago. So they'd seen the asset owner had seen this drone through the content which Flyability had been pushing out, and wanted to take a closer look at it. So Flyability flew over to China and basically performed this proof of concept, which they were blown away by, just by the quality of data and the ease of use, and subsequently then purchased it to have that capability on board all the time. I think they got probably 3 or 4 operators from various people who's going to be on the board boat, to be able to call them in on hand, maybe if the boat's out of dock, to be able to use that as and when required. So
Ed's popped a question up on chat asking, what is the battery life and fly time?
So the battery life on the Helios 2 is 10 minutes, which might not seem like a lot of time, but I can assure you in that sort of application, it's very, even though easy to fly, if you're flying in them sort of environments, can be quite hard on the old brain. So it is 10 minutes flight time, but they can be swapped out within seconds. So we normally, when it comes to them kind of applications, you're continuously monitoring the signal strength from the RC to the drone, as well as the battery levels as well.
Okay, thanks very much. Any more points before we let the guys go?
Brilliant.
So in which case, I think, you know, a big thank you, George and James. Thanks for sharing, I guess, in the next generation.
No,
but it's here now.
Exactly, yeah, no problem. In fact, thanks for having us. If you do have any further questions or anything, please give myself or George a call on the details below, or contact yourself, probably Mike, and you can push their details onto us.
No, that's fantastic. Thanks ever so much, guys.
Perfect. Have a good day. Thank you.
All the best.
Thanks, guys. Cheers.